Hey there, Joel here, and welcome to this online class. Today is the part 2 video of the chapter Integers of class 7th Mathematics. If you haven't watched the first video, then please go ahead and tap on the link in this I button or down in the description box or at the end of this video. But do watch the part 1 video first so that you understand what's going on in today's class. Before that, let's roll this intro. After knowing how to write integers, we said that integers are nothing but numbers starting from negative infinity to 0 to positive infinity. So we can include all the numbers that are negative and positive under the category of integers. We learned how to write them. Let us take an example now in a form of a word problem. In a quiz, positive marks are given for correct answers and negative marks are given for incorrect answers. If Jack's score in 5 successive rounds were 25, -5, -10, 15 and 10, what was his total at the end? So to understand this, first let us remove all those integers and write them down. This is what it will be. Then what I will do is I will write the negative numbers together and the positive numbers together. So now this step is only to make sure that when you are doing the calculation you don't make errors. So this step is not compulsory, but if you do it then you probably reduce your chances of making a mistake. So writing these numbers in here, these numbers solve a lot of problems. So we write -5 and -10 together, and this 25, 15 and 10 over here. Now we know we have two negative numbers and we want to add them. Same sign we add, right? In the first video, if you remember, so negative and negative, so minus and minus plus, which will give me 15, sign of the greater number. So whenever we do addition and subtraction, we have to ask that question, sign of the greater number or statement. So sign of the greater number, that is -10, so minus comes to the next number. On the other side, the other part of it, which is there, 25, 15 and 10, they are all positive, so same signs we add all together and you will get +50. Now I have two integers, -15 and +50. So when you have different signs, we subtract. So 15 minus 50 is going to give me 35, and then sign of the greater number, which is positive, so +35. It is that simple to solve these problems. All you got to do is remember that what signs I use, and when there are two signs, put a bracket, and same signs we add, different sign we subtract, and ask that question, sign of the greater number, which one is that? So hope this part is clear over here. Let's move ahead and solve a different kind of a question. Now here you are asked, verify a minus, in a bracket, minus b is equal to a plus b for the following values of a and b. Now whenever you are given a question where you are asked verify, all you have to do is take the left hand side and right hand side separately. Now what is the left hand side in this question? A minus bracket minus b is my left hand side. Whatever is there on the left of equal to becomes left hand side, whatever is there on the right side of equal to become right hand side. So write this thing down, and it will be so I have written LHS and I have written RHS. Now what we are going to do is Below that, there are 4 different problems over here, and they have given A is 21 and B is 18. So all I will do is, wherever there is A, I will write 21. Wherever there is B, I will write 18. That's it. Nothing else changes. Everything remains the same. So left hand side and right hand side written as it is, and just substituted the values. Now, if you look at 21 minus bracket minus 18, now there are 2 signs, that's the reason there is a bracket there. Now I need to remove that bracket from there. So what will happen? Minus and minus will become plus. So it will become 21 plus 18. Okay. Same way on the other side. So this is, after addition you get 39. So this side will become 21 plus 18, which is equal to 39. So I hope this is clear. If you still have doubts with this particular problem, rewind a little bit, watch it again, and once you are confirmed that you know it, solve the other 3 problems for 118 and 125, 75 and 84, 28 and 11. Solve it for the same question but solve it for different numbers and write it down on your notebook. So the left hand side and right hand side is equal, hence we can say it is verified. That equation that is given to you of left hand side and right hand side, we can say it is verified because we get the same answer. Next, something called as closure property. Now, say for example, I have 2 glasses of water, okay, and then I add them, put them together in a small bucket, okay. So 1 glass of water poured, second glass of water poured. What will be the result in the bucket? Will it be some kind of a soft drink or some kind of a juice? Stupid question, isn't it? But the closure property is something like this. So it just tells you, the property itself says that if I add, okay, 2 numbers or 2 integers, will my result be an integer? That is what the question is, or the property says that it has to be like that. So there are times when certain numbers do not follow this. We're not going to discuss about all the kind of numbers. If you with that question, no, why is this sir saying there are different numbers? Numbers are numbers, right? If you watched my first video, I have explained to you that there are natural numbers, there are whole numbers, there are integers, rational numbers, irrational numbers, real numbers, and so on. Okay, so when you're checking about closure property, you might have to check for all the possible different kind of numbers. So in this chapter, we are only talking about integers. So let us take the same example with respect to some numbers. Okay, so 3 is an integer, 7 is also an integer. Both are positive integers. So when you add them, my answer is 10, and 10 again is an integer. So closure property verified, isn't it? But no, you can't use just one example and say yes, it is verified. You need to use a couple of examples. So let us take a few more. 8 plus 5 is equal to 13. So 8 is an integer, 5 is also an integer. When you add them, you get 13 as your answer. Again, verify 13 is an integer. Now we'll take 2 negative numbers and add them together and see if we get an integer. So minus 2 plus minus 6. Again, there's a bracket because otherwise those 2 signs would have been close to each other. So this would be minus, okay, minus 2 will remain as it is, plus and minus will become minus. So minus 2 minus 6 together will give me negative 8. Now if you have problems with regards to what will be the answer, then I'll recommend you please solve the numbers maybe in a rough column and then write the answer. Don't blindly copy these problems and say it's done. No, you please verify that minus 2 plus minus 6, are you getting minus 8 as an answer? So verify that on your notebook and then write the answer. You might get minus 10 or minus 12. I don't know. Check. Next, I'm again taking two negative numbers, adding them. For in this case, my first number is a greater number which is negative. So my answer to that is minus 13, which is also an integer. Now, minus 9 plus 1. So I have a negative number or negative integer and a positive integer. Will my result be an integer again? Yes, it is an integer. So minus 8 is an integer. 23 plus minus 3, result is 20. So here again 20 is an integer. So my closure property is true under addition of integer. Now if you notice carefully, in all these examples, all that I have done is taken two integers and just added them to see whether we get an integer or no. Now this closure property could be applied for two integers and subtraction, or two integers in multiplication, two integers in division. So remember that when you are doing this property, closure property just gives you an idea, okay, what you have to do. But when you substitute integers, will your result be an integer? Or if you have taken two natural numbers, will your result be a natural number? Or if you have taken two rational numbers, will your result be a rational number? Is what you check with these properties. Okay, so I hope this closure property is clear under addition. If so, then let's go ahead. Again, I have a bigger glass of water and I have a smaller glass of water, and I subtract this water. So what will I get in the bucket? Result will be water only, right? And not soft drink and not juice. So same way, let us use the same example with numbers or with integers. So 4 is an integer, minus 8 is again an integer. When you subtract them, is my result an integer? Minus 4 is an integer. So I'll just move a little bit fast over here since you have got the idea of how do we calculate this. So 9 subtracted with 6, so answer is 3, again an integer. Minus 3 minus 7, so I have taken two negative integers, subtracted them. What is the result? Result is answer 4, which is a positive number, but it is also an integer, so works good. Same way, minus 11 minus 4, result is minus 7, again an integer. Minus 9 minus 1 gives me minus 10, again an integer. 23 minus 3 gives me 26, again an integer. So the closure property is true under subtraction for integers also. So closure property holds true for addition, closure property holds true for subtraction too. You can try for division and multiplication. You can take the same examples and try, or if you want to take different examples, you can do that as well. So once, all you have to do is take two integers, multiply them and see whether your result is an integer, and try out with different combinations of numbers. You can start with two positive integers, then you can take two negative integers, then you can take one positive, one negative integer, or you may take one negative, one positive integer, and finally two negative. I've already told you. So take all the combination of these numbers. You can see over here, right? I have taken positive and subtracted. Again, second one is, the first one is a bigger number, second one is a smaller number. Then I have taken two negative integers. Again, second one is bigger, first one is bigger, second one is smaller. Then I have taken one negative, one positive, and then subtracted it. And here I have a bigger positive number and a smaller negative number. So take all these combination of numbers and then try it for multiplication, try it for division as well. Let us look at commutative property. What do we mean by the word or this property? I have, a teacup and I put sugar in this first and then I pour tea. Or if I have tea first and then I put sugar, will the sweetness of the tea change if I put the same amount of sugar? And the answer to that is no. We'll use a similar kind of an idea when we are talking about commutative property. So what is the property telling you? Whether I add the a, that is the first number, and then second number, or add the second number and then the first number, will my result change? It should not change as per commutative property. So all that we are doing is taking this property and then we are going to apply different integers in this situation and check whether the answer that we are getting, is it going to be same or it's going to be difficult or different. So I have 3, which is an integer, 7 again an integer. I'm going to add them and check the answer. In the second case, I'm going to add the 7, which is first, and 3 later on. Okay, so whether you eat like this or you eat like this, food is gone in your stomach, right? So similar way of looking at this. So the answer is 10, which is an integer. Let us take another example. 8 plus 5 or 5 plus 8. When I do, I get the answer as 13. Try minus 2 plus minus 6 or minus 6 plus minus 2. The answer to that is minus 8. So minus 10 plus minus 3 or minus 3 plus minus 10. So when I do that, my answer is 13. And for the last example, minus 8. Okay, so what do we understand here? In both the ways, whether I add a plus b or b plus a, my answer remains the same. So I can say the commutative property is true under addition of integers. We have taken two integers and we have added them. Okay, now let us try the same thing for subtraction. So commutative property a subtraction b or b subtracted from a. When you do that, now in this case, when I do 3 minus 7, I get my answer as minus 4. But when I do 7 minus 3, I get my answer as positive 4. Both are integers, but they are different. In the second case, maybe this was the only first case that it was incorrect. So let us try some more examples to check that. 8 minus 5 is going to give me 3. And 5 minus 8 gives me negative 3. Again, two different integers. Or if I take minus 2 minus 6. If I do that calculation, I get 4 as my answer. And minus 6 minus 2 gives me negative 4. Again, two different integers. Same way, we can try for another example. And maybe one more example. So in all these cases, when we are checking commutative property, for which operation? We are doing it for subtraction. My answers that I get if I change the order is different. So I can say that commutative property is not true under subtraction of integers. So I hope you are very clear. First we look at the property and then we try it on different operations. So first we try with addition, then we try subtraction, then you can try multiplication, and you can try division. And finally, if you get same answers, then we can say that it is true, this property holds true for that particular operation, whether it is addition, whether it is subtraction or multiplication or division. And if you get a different answer, then you can say that this property doesn't hold true for that particular operation. I hope you are very clear with this commutative property. And if you're still eager to learn more properties, let's try associative property. But if it is too much for you to grasp in one video, then I would suggest you can stop the video for today and continue it honestly, okay, tomorrow or after a while when you are, fresh in your mind to learn a little more property about this. So when we are talking about associative property, what are we looking at? Here we are taking sugar and then we are going to add milk and water together, or we are going to add milk plus sugar and then water. Will this property be true for addition? That is what we are checking. So I have written the property over here for you. 1 second. Okay, here. So A plus B plus C is equal to A plus B plus C. So that is what we are trying to check. Okay, so we'll try and substitute the sugar and milk and water with some numbers over here. Okay, so I have 3 plus, or we're adding 3 with 7 plus 1 together, and we'll check what is the answer. And in the second case, we are going to add 3 plus 7 together and then add 1 to it. So the answer in both these cases is 12. So can I say associative property is true for addition for integers? I can't, because it's just one example, right? Let's take another example. Minus 2, which is a negative integer, and I have minus 6, which is again a negative integer, plus 4. So 6 and 4 together and then 2. What is the answer? Answer is minus 4 in one case, and in the second case also it is the same. If I change the way I'm going to add those two numbers, same way, let us try over here. Negative 10 plus negative 3 plus 2. So I'm going to add this. So negative 3 plus 2 will give me negative 1, because same different signs we subtract. So 3 minus 2 is 1, sign of the greater number, which is minus 1. So minus 10 plus minus 1 is going to give me minus 11. In the same way, I'm going to do it for the other number, that is minus 10 plus minus 3. So it will become minus 13 plus 2 will give me negative 11. Same way, you can try it for this number. You can pause the video and write down the answer in the comment section. Okay, and the answer is minus 3. You can try this one too. Okay, so after looking at all these answers, I can say the associative property is true under addition of integers. So if we are going to add integers, okay, using the associative property, it is true. The same thing, you can try the associative property for subtraction, for multiplication, and even for division. So we are trying it for subtraction now. So I'll go a little bit faster. You know the drill, how to work it out. So let's just take one example slowly first, and then we'll speed it up a little bit. So 3 subtracted, okay, from a combination of 7 minus 1. So first of all, let us solve the bracket. 7 minus 1 is 6. Okay, positive number, negative number. What do? Subtract. Sign of the greater number, so positive 6. Now I have 3 minus 6. So that will become minus 3. If I change the order, I get minus 5 as an answer, because 3 minus 7 is going to give me negative 4, and negative 4 and negative 1 together is going to give me negative 5. So in one case, if I change the order, I get minus 3, and the other I get minus 5. Let us try another example. And if I do that, this calculation, you can pause these videos, and please students, I recommend, don't watch these videos as if they are that's a movie that you are going and watching it, but please pause these videos a number of times and solve it so that you don't make mistakes and you really understand. Because it's not just, I have just put and made it into a presentation. I'm putting it across to you. I have practically solved them so that I know that I'm doing. And if I do it, I'm just becoming better in solving these problems. But if you just watch the video, then you are just becoming better in watching the video but not practicing and able to solve them. Because as you watch, it might look as easy as possible. That's because I'm trying to make it that way. But if you don't solve, then you are going to make those problems as difficult as for you. So please pause the video, solve these problems. Okay, you can keep the phone aside, solve them, and then compare your answer with what I have written. So please do that. So the answer over here is 8 and -8. Again, two different integers. Let's try another one.